All right, today we're going to be doing our spinach leaf lab. If you recall, the last time we were able to meet in class, we did our cell respiration and photosynthesis notes. For those notes, we should have learned what the formulas were for cell respiration and photosynthesis. We went over those in detail, both in the PowerPoint as well as a class discussion. There is the formulas in case you did not catch those. So the first one was an example we did with methane burning. The next one there is our example of photosynthesis, where we take water and carbon dioxide and light energy, and through the process of photosynthesis, a chemical change occurs producing sugar and oxygen. And then we talked about how those need to be balanced. You will not have to balance chemical equations in this class, but I wanted you to understand that the same amount of matter that goes in is the same matter that we get out, something we went over extensively in our chemical and physical change unit. The bottom formula there is the formula for cell respiration. And the big take home was that the products of photosynthesis are the reactants for cell respiration, and the products of cell respiration are the reactants for photosynthesis. So that's kind of where we're starting. We want to investigate this concept of photosynthesis and look at some components of that. So let's look at our assignment. What I'd like you to do is just go through and answer these pre-lab questions. And then this is the question we're going to investigate today in our lab. Does the color of light impact the rate of photosynthesis? So our claim is that green light will make photosynthesis happen the fastest because plants are green. That's the claim we want to investigate. So to do that, we need to get a baseline of what does white light do, right? What does white light do? How quickly does photosynthesis happen when we use white light to power the process? And then we're going to use different colors. We may even not do any light at all, or at least try and restrict as much light as possible to see how that impacts the rate of photosynthesis. So in the next video, I'll explain how that process will work, what experiment we're going to do to be able to accomplish this. The materials we're going to need today are a metal paper hole punch, a 10 milliliter or larger plastic syringe without the needle, a light source. We're going to need multiple colors, so we'll have multiple colored light bulbs. We need fresh spinach leaves. We need two 200 milliliter beakers and one 500 milliliter beaker. And I have those all set up over on one of the tables. Okay, so our procedure, we'll go through and read this together, but I'll actually perform the experiment for you. So fill both beakers with water. Use the metal hole punch to cut 10 circular discs from the fresh spinach leaves. Try to avoid the thick veins of the leaves. Separate the two parts of the syringe. Drop 10 of the spinach discs inside and reassemble the syringe. Push the plunger almost to the bottom, but don't crush the discs. Draw at least 5 milliliters of water into the syringe. Gently squeeze the syringe until liquid begins to come out. Put your finger on the end of the syringe and draw the plunger back and forth slightly, creating a partial vacuum. Repeat until the leaf discs sink in the water. This action forces the liquid into the interior of the leaf. So the goal here, even though it doesn't seem like it, a leaf has pockets of gas in it. And that makes the leaf less dense than water. So that means the leaf floats when it has the gas in there. So when we do this suctioning in the syringe, what we're hoping to do is force the water into the tissues of the leaf and pull gas out of the leaves. And so what that will do is it will cause them to be filled with liquid instead of gas. And as a result, their density will increase and they should sink to the bottom. Well, over time, as we shine light on the leaves, they will do photosynthesis. And one of the products of photosynthesis is oxygen gas. And so they're going to fill the leaves back up with gas. And that's going to make them less dense than the water around them, which should make them float back up to the top. And that will tell us, give us an estimate of the rate of photosynthesis. We're going to count how often this is occurring. So let's continue down. So we pour the contents of the syringe into a 200 milliliter beaker, swirl the liquid to keep the discs from sticking to the sides of the cups, and then let them sit. So they should sink down to the bottom. Then you will take the beaker and place it in a dark cabinet or closet. After 15 minutes, check to see how many discs are floating. So that's going to be our first one, without light. Next, we should repeat steps 1 through 10, but this time we're going to place the spinach leaf discs near a light source, white light, and then we will watch every 30 seconds and count how many of these discs are floating every 30 seconds. And so we should be able to pick up a nice set of data about how this is changing as we put it up there. So we'll do that for 15 minutes. And then we'll repeat steps 1 through 10, this time not using white light, but instead using a different color light. And I'll do multiple colors so you'll all have options to look at. And so we'll do the lab, you'll get the data set, and you can fill out and answer these questions. All right, here's our spinach leaf. You can see the veins, it's the top side here, the underside there. Okay, so all I'm gonna do is take this hole punch and punch holes in it, just like I would a piece of paper. And we will get, hopefully I'll do about 30 of them, and I'll show you what they look like in the next video. All right, here is 10 spinach leaf discs. And I punched out another 10 over here. As you can see, this is what it looks like when you haven't pulled the gas out of them. See how they're all floating on top of the water there. So what I'm gonna do is I'm gonna use this syringe, and I'm gonna suction all the gas out and force the water into the tissues of the leaf, and they should be sunk, they should sink after I do that. So I won't video me actually doing that part, but just so you understand what's gonna be happening. All right, here is the spinach leaf discs after I suctioned the gas out and pushed the water into the tissues. So as you can see, they're all down at the bottom of the beaker instead of floating like these guys over here. So what I'm going to do now is go and take and put this into a cabinet with no light, and in 15 minutes we'll see how many of these discs are floating. Okay, I just suctioned another 10 discs, and they're now down in the bottom of this beaker. What I'm going to do now is I'm going to do white light to see how white light affects the photosynthesis of our leaves. This is going to be kind of our control group, right? We're going to see, well, if all the colors of light are being used, all the frequencies, what is the rate of photosynthesis in that case? We also have the one in the cabinet that we're letting sit for 15 minutes in the dark. We're going to see how that looks, so how photosynthesis looks without light. Well, hopefully you know enough now from our discussion of photosynthesis to understand that the one in the cabinet's not going to have very many discs floating at the end, but this one should. So we're going to turn this on, and every 30 seconds we'll see how many discs are floating. Notice that I put a larger beaker in between, so the light will pass right through that, no problem. But what I don't want is the heat of the lamp making the water less dense and kind of messing with my experiment. So I put the larger beaker there to absorb the heat from the lamp, but the light still passes through. So what we expect to happen is as the light hits the tissues of the leaf will do photosynthesis. These leaves, I removed, like I said before, the gas from the leaves. So what should happen is, as it does photosynthesis, as we can see there on the whiteboard, oxygen is one of the products. So oxygen gas should start to fill the tissues of those leaves, and we should get the the leaves starting to float up as they do photosynthesis. So as they float up, we count how many are floating every 30 seconds.